All right, so our next Delta Math section is select explicit formula for the sequence. So let's go ahead and click on that. What is the formula for the nth term of the given sequences? And it's given it to us in multiple choice. And they want the explicit formula. It looks like we've got 10, 50, 250. So let's hop over to our sketch pad and we'll try some stuff. Grab my pencil. And we know our arithmetic sequence explicit formula is a sub n equals a sub 1 plus d, our common difference, times n minus 1, where n is the term number. And our explicit formula for our geometric sequence is g sub n equals g sub 1. Oop. Undo. Hang on. All right. It is, I'm sorry, I was just rolling. It's g sub 1 times our common ratio raised to the power of n minus 1. And let's see here. This case, they give us 10, 50, 50, 250, dot, dot, dot. It's an infinite sequence. And it looks like we're multiplying by 5 between each term. And if you're not sure about that, you can take your second term, divide it by your first term, and it looks like we are. So that gives me a geometric sequence. So g sub n equals my first term, which is 10, times my common ratio, which is 5, raised to the power of n minus 1. And let's see if they've got that in our Delta Math. No. They do not. They have 5 to the 1 minus n. They have 1/5 to the 1 minus n. They have 1/5 to the 1 minus n. And they have 1/5 to the n. So that means that we need to simplify. Okay? And when we have an exponent like this, we can use our properties of exponents that we learned last year. We know this is the same as 5 to the n times 5 to the negative 1. And 5 to the negative first power is the same thing as saying 1 over 5 to the first power. And I can multiply, I can use that commutative property of multiplication to rewrite it. Let's see here, that's multiply. That means multiply. 1/5 times 10 times 5 to the n. And 1/5 times 10 actually gives me 2 times 5 to the power of n. And if we're not sure if that works, we can, try out a couple, right? G sub 1, we'd have to do G sub 1 would give me 2 times 5 to the first power, which 2 times 5 is 10. If I wanted to find G sub 2, I would do 2 times 5 to the second power, and 5 squared is 25, times 2 is 50. If I wanted to check my third term, I would do 2 times 5 to the third power, right? So 5 cubed, following PEMDAS, 5 cubed is 125. Right? 2 times 125 is 250, and it looks like each of my terms check out. Okay, so I'm going to hop back over to Delta Math. I'm going to click this one. What's going on here? I said 2 times 5 to the n. Why are none of these matching? All right. They're not giving me a good matching sequence, which is making me frustrated. So let's see here. We could try 1/5 to the first power times 10. That's not going to work. 1/5 to the 1 minus 1. Oh, that's not going to work. 1/5 to the 1 minus 1 would be 1/5 to the 0 times 10 is 10. 1/5 to the 1 minus 2 gives me 1/5 to the negative 1, which is 5 to the first power. I'm going to go with this guy right here. Let's click submit. I did that by plugging and chugging and knowing my exponent properties. Okay, they gave it to us in a challenging way, but we still persevered through that problem. Okay? And they're saying just plug in n equals 1, 2, and 3 and see which ones give you 10, 50, and 250. That's Delta Math's suggestion. Let's try a new problem. 15, 21, 27. This looks like arithmetic. So if we try a new, right, so we want to remember our explicit arithmetic formula is a sub n equals a sub 1 plus d for our common difference times n minus 1. And they give us 15, 21, 27. So we want to think what's changing between each term, right? And if we suspect it's arithmetic, we're looking for the common difference. So we're going to take 21 minus 15. That means we're adding 6. If we do that between 21 and 27, it still checks out. So we're right, it is arithmetic. So I'm going to do a sub 1 equals my first term, which is 15, plus my common difference times n minus 1. And let's see if they've got that as an option. 15 plus 6 times n minus 1. They do. They may want it simplified even more. If we want to simplify it, right, we would be doing our distributive property. So, messy handwriting. 15 plus 6n minus 6. 15 minus 6, using that commutative property of addition, we would do 15 plus negative 6 plus 6n. 15 plus negative 6 is 9, which would be a more simplified version. But I want to see if they will let us do, they don't have that option, right? So hopefully it gives it to us in this version. Cool. And we got it. So sometimes they want the simplified version. Sometimes they don't offer that as an option. You guys got to know how to do both. All right. And that's it for that one.